Okay, now we should be live. Let me double check it, because yesterday I've messed up a little bit. Yes, we should be live. So yesterday I thought I was live streaming, but I was not, because since I'm still new to live streaming, I couldn't figure out that that the stream hadn't started. I'm sorry, guys. Let's see just a quick recap of what we have seen last time, and then we'll dig into idioms. So since I've streamed yesterday, I will have code already written. I have tried to stream yesterday. I already have some code written, so we'll go through that code, and maybe this is also a different approach to learning, which you might like. I don't know. You will tell me in the chat if you want to. So I have created these Google Slides inside my Bitbucket site, and inside my GitHub site. And here you will find all the recaps. They are very quick recaps of what we have done in the previous lessons. So we have just seen basic syntax lesson, and we have seen how to use functions, variables, which can be immutable with val and immutable with var. Then we have classes, which define objects and properties and methods using the class keyword. And then we have seen conditions with if, else, or when. And then we have also seen loops a little bit, while and do while loops, and also we have seen how to use ranges and collections. And at last we have also seen nullable fields, nullable values, which can be defined with a question mark at the end of the type. And we have seen the use of Elvis operator, but very quickly, if I remember right. At last, we have also seen how to do casting. So casting is the operation that converts one type to another, and it is possible with as. If you use as with question mark, then if the casting is not possible, it will give null. So it is called safe casting for this reason. Now we can go to the idioms documentation, and we'll have a walkthrough and compare this to the code that I have written. So this is from last time, from the first lesson, and we had created. Let's recap very quickly. We had created, here you already have some new code, but we have created general computer as an open class with some values. These values are immutable because they are defined with val, and we also have declared manufacturer, which can be nullable. So there might not be manufacturer defined when you want to create an instance of general computer class. And then we have seen how to create a class that inherits from general computer, the open class. And same thing here, we pass the parameters from laptop to general computer. What we had not seen is that we can also define some values, predefined values for the arguments, just with the assignment. And we've also done this here with the hinge, and also with null, because actually this is also assigning a null value there. So what we had done was we had created an instance of that class. We have used the print manufacturers function, which prints all the available manufacturers. Then we wanted to see how the toString method is working. And basically, it is this function is now overriding the toString method, and at last, here we have a condition to check if manufacturer is null. In this case, the manufacturer is null. As you can see, we have not defined it, so it would return true. Now let's go on with the idioms. So the first idiom that we see is a data class. Basically, a data class is a class which holds some data inside, and it has some convenience methods or functionalities. First of all, just as with classes, you can have getter and setters for all the properties that you define. The properties are name and email in this case, and in the setters are only available in case you declare a variable and not a value, as in this case. We'll see this in the example that I made. Then we have other methods like equals, hashcode, toString, and copy. The most important ones here are equals and copy. Basically, the copy will copy all the values that you have defined in your customer, and they will be copied to a new instance. And in the new instance, you can also say, okay, copy, but override name or email. And you can do that by setting the parameters inside copy. We'll see this in the example. So first of all, what I've done here is I've created a customer, just as they are doing in the example. And here I've defined two properties and one more, which is a variable. So we have name and email, which are values, and variable surname. Okay. So in this case, this is the variable. This value can be changed. In fact, here I am printing email and name and surname. Then I'm setting a new surname for the customer, and you will see that the customer will have surname Bianchi instead of Rossi. Let's run this to see the result. So if I was to comment, if we were commenting this line, then we would have surname Rossi, of course. You cannot change variables values when you define values. So let's see here. Sorry for the mess, but this is the code that we're looking for. So email is am.rossi. Then we have name Mario, surname Rossi. Okay. Maybe. Yeah. And surname Rossi. And this is what we're printing here. Then we're changing the surname, and we're printing the customer with the toString method that we have overridden, which is this one. So customer is Mario Bianchi because we changed Rossi to Bianchi, and the email is the same. Then what we have done is something more advanced. We have used the copy method. So if you see, I will type it because it might be more clear. If I say customer.copy, it will allow me to override all of its variables, all of its values, name, emails, and surname, and it will create a copy with those values. And in this case, I'm creating a customer too with the name Giovanni. and so this is possible. Second example, just for the purpose of clarity, because I want to show you something in the next line. We can create a copy, exact copy of the customer. So if we compare the customer and customer 3, the result that we expect is true. So in fact we will say compare data classes, then the result is true. If I was to compare with customer 2, of course it would give false. But we have not used data classes in the previous example. In the example from lesson 1, we have only used normal classes. And with normal classes, since they work by reference, you will not have equality if you compare two normal classes, even though they have the same values in their constructors. That's because they are compared by address and not by values. Data classes instead have their equal operator will compare each of their value. Okay. So as you see here, comparing two normal classes, although they have the same parameters, they do not give the same result as before, so they give false. Okay, next. What we see next is default values for function parameters. Okay, we've seen this already. Well, let's go to filter. So we can use filters to perform some cool operations. For example, remember we had defined all the possible manufacturers. In the last example, I've added some of them, and I've made this nullable, as you see here. So this string list is nullable. And what I've done here is I've said let's filter only those who start with parameter A. With a letter A. Okay, so it takes basically the string from possible manufacturers. It cycles through the list and takes only a list that contains those starting with A. And if the value is null, then we also have the Elvis operator and say don't pick this value. Okay, so here filter basically it is a function, an inline function, and it's defined with the generic operator, but we will see this in a later episode. And it returns filter 2 by passing an empty array list and a predicate, which is what we're seeing, like starts the check starts with, and we pass it here. Basically what this does is it cycles through the elements, it checks the predicate with the given element, and then if the predicate is matching, then it adds the element and returns the list destination. So what we can do next is we can check the presence of an element inside the list, and we are doing this here with BenQ and Lenovo. So yeah, Lenovo is not there, so it will give false, and BenQ is there, so it will give true. Yeah, as you see here, this was the result of possible manufacturers starting with A. Okay. Next, yeah, we can use. Yeah, I've skipped reading start on input because I've not checked what the issue we had in lesson number 1. We have seen instant checks already, I think, or no, maybe not. So I will check very quickly. Yeah, we have used instance check here, so to check if the object is a string. I had changed this function a little bit because in previous lesson we were not passing a nullable. Now we can also pass null, and it will still work because it will return null if the object is null, because it will not match the type string. So it will go directly here. If the object is a string indeed and has a length of greater than 0, then it will return its length. Okay. So this is instance check. Why it scrolls like that? I don't know. It's a little funky. So a read-only list. Okay, this is just list we have defined. Read-only map. We have done something more cool in this example. We have created a map from our list, and we have given it a code. So we have a list of strings. In here we're mapping this list of string. Wait, was this a map? Yes, I think so. So we're creating a map with the map function, inline function, and we basically, for each element, we're capitalizing it. So Acer will become capital A sir, and we'll then print this list. Yeah, it's gonna be here. So basically it's a very easy code. Here we're using the object that we'll see later, so don't worry. Capitalize, basically it takes the first letter, makes it uppercase, and then includes also the substring from 1 to the end of the string. Else, if the string is not is empty, sorry, it will give empty string. So yeah, this is just one way to capitalize. Next, so we have made a map. We know how to use map now. Why is it scrolling so badly here? Maybe I have to use the arrows. Yeah, map. Access a map entity. It's possible to access a map entity with the braces, with the square brackets, or with .get. You can also cycle through the elements inside a map. Basically, a map contains keys and values. You can have only one key. You cannot have duplicate keys of the same value. For example, you cannot have a key of A and another key of A. You can only have one key of A, and this key will be to this key you can assign a certain value, and you can also change this value if you want to. Let's see if we have done something in the example yesterday. So okay, yeah, here I was doing the typecasting check that we saw before. So basically we were checking if 3, which is converted to integer or null, is an integer. If it is an integer, it will print we're now sure it is an integer. Remember to say is int, because this will check the type of the element inside the when. Let me check it here. Yeah, we are now sure it's an integer, and we're here. If I was giving chow, then it would give null, and it will go inside the else. Okay. Next, so we're printing now the manufacturer codes. Basically, what I've done yesterday was I've created a map. This is a map of strings and integers. So basically, starting from the manufacturers, I have assigned a code to each of these manufacturers. And this by creating an integer array, as you see here, that gives a certain value, and for each manufacturer it assigns a certain code. Okay, this is because we're also seeing how int array works. Basically, int array, as it's written here, it creates an array of integers of size given, and this array is filled with zeros. Okay, so yeah, all elements are instantiated with zeros. In this case, we want to change the elements, and we're doing that by using this piece of code. So we take it, we add 10, and we add the code index, which changes over, not over time, but in the cycle of these values. Then, so basically we were creating a map from a list in this case, and we are assigning the value like you see here. So C is the integer code's manufacturer index is basically giving the code, and associate with will basically say take the element from the list, take this, and this is now the key, and C will be the value. So we have string and integer, string as key and int as value. All right, let's go next. So since we can only have one key and not multiple keys with the same value, the null here will collapse to one value. We'll only have the last code you see here. So this is our map that we created, and this value is not what you might expect. It will be the last code inside the codes list. All right. Next, we're printing out let me see what we're printing out. Yeah, here I'm printing the manufacturer codes of Acer, and it's giving 11. I'm also printing the keys and the values in this way, so you can always access a map keys and its values with this way. And these two are lists. This is map syntax for toString. Next, I'm printing each key and value of the map in this way with key value. It's just a different way of seeing things. Then this code only runs when accessing built-in manufacturer. So we're also seeing, we'll see it here, lazy property. So basically a lazy property is a property where the value is computed only when it is accessed. So how should we use it here? This is not very clear in this snippet, but it's more clear here. So I've declared a string which computes its value when it's called. In fact, as you see here, I'm printing built-in manufacturer. You can see it here, and the print line is written here in the terminal, and not when we instantiated the laptop class. This is because we're using lazy, and this is useful, for example, if you want to check the value of a certain property of a laptop, like has manufacturer, and you want to return a value of yes or no based on what has manufacturer value is. So yeah, you will see the code runs here, and if I print this value, which is built-in manufacturer, we'll get a value of yes, because in laptop we have a manufacturer, and so the has manufacturer is yes, is true, and then this value is yes. Okay. Next, we can, yeah, we're outputting this. We saw it before, but basically we have done a little trick here, which is we have defined an object. We'll see this here. An object is a singleton, so basically it's an instance that let's see the explanation. Kotlin explanation of how what's an object. So object declarations. Okay, so in Kotlin, objects allow you to define a class and create an instance of it in a single step. This is useful when you need either a reusable singleton instance or one-time object. So it's a little bit not very understandable here. Let's see another explanation. Yeah, an empty object can extend no class. It doesn't convince me. Okay, so yeah, the object basically is something that is defined inside the code only once, and it's not as classes where you can have an instance of that class and then another instance of that class, like we're doing with laptops. You define an object only once, and it will not yeah, this object will not it's not that it will not change, but it's usually, let's see if we no definitions. Okay, yeah, they have some features like they can extend classes and implement interfaces. In fact, here what I was doing is I was creating an abstract class basically an abstract class is something that needs to be implemented. So as you see here, this is abstract, and this means that the objects that are implementing it need to implement these two methods on their own. We're doing it here. We're basically doing the same thing inside these two objects. This is a companion object, so it's an object of the general computer class. It's like in here you can define static functions that you can use without creating an instance of general computer. That's why companion objects are useful. In this case, instead, we created an object which is private and not usable by some other parts of the code. They can only be used. These two functions can only be used inside this class. In fact, if you see here, I'm using utilities capitalized. What I could have done was also, since manufacturer is a string, I could have done manufacturer dot and then string capitalized, because it will take the companion object instance and then it will take its function. This is an inline function, so basically you are defining the type here, and you are accessing the string with this in this case, and so it's the same. Doing this or this is actually the same. The advantage of a companion object, as we said, is that you can access this outside general computer, outside general computer code. Let's see if I can show it. Here it's a little bit of a mess, but you can see that if I write dot, if I don't have this in my way, why should I? Okay, I can access capitalize, and I can say hello, and when I click here, it gives me companion object instance. Of this function, right? You can see it. And if I was to access utilities, I mean, you cannot do it because it's private. You see? It will say unresolved reference. So basically these are similar to static methods in Java, if you have done Java before. Okay, next, I will go next because we have still some things to do. So here we have instantiation of abstract class that we just saw. This will skip it. Okay, execute a statement if we have null. So I'm doing something a little bit different in this example. Basically, I'm creating a list of strings, sorry, but I'm making it empty, and if I call last, it will throw an exception because I did not call last or null. So last will throw an exception. If you enter this function, you will see that if the list is empty, then throw no such element exception. The list is empty. You can see it in the code as well. Should be right here. But instead of trying and catching with this function, there's a better way to do so in Kotlin. You can use the last or null function, and this will return null if the list is empty, else it will return the last element inside the list. But it's better to always use last or null, I mean nullable elements, because exceptions may break your code. If you don't catch them, they may break your code. And imagine having to check the last element after tons of code in here. So like this, not like this, but with a lot more code. But the idea is it would become not readable. Prefer last or null for readability. Okay. Next, we have the use of width. Let's check it. Okay, here we go. Basically, the width allows you to call methods and properties of a class without having to specify the class name. Yeah, the instance name of this class. For example, if we have a laptop, we can say with laptop, and then we can access directly the possible manufacturers without writing laptop dot possible manufacturers. So if you need to access lots of properties and methods of laptop, this can be really useful. I wouldn't suggest nesting it with other widths, although this is possible. It might become harder to read. I don't know, it depends on your preference, of course, in this case. Maybe if you do this, it could be more readable. I don't know. You have to try and see what fits in your code. One more thing that we'll see in this lesson is the apply. So basically, apply can with apply you can specify new values to your object. So for example, we have customer, which is instance of customer, and here remember we had surname of Rossi. What we can do here is say surname equals different surname. So like I don't know, like Python, and we can print surname. So as you see, with apply you still can access this, and you can also make the print of it. So in some way, with and apply are similar between them. Then you could also say use the also function, sorry, and this allows you to in this case you need to access the customer with IT. So as you see here, it's also suggested you can say also print line IT copy, and you can also do that. Let's see what it does here. Yeah, we changed the name to Paolo, and it's still working. Let's see if we run everything, what happens. So yeah, we're printing Biden. Yeah, here it's missing print line. We're printing Biden, and we're printing then the copied instance to Paolo. So we have Paolo Biden actually, right? I hope you understand what is happening here. And if we print line customer now, let's see the difference. So we have, yeah, as you can see, so inside the apply, the change is sticking to the customer, let's say. Inside, yeah, in the also instead we are making a copy, so this is not being changed inside customer. We'll have a new copy which is Paolo Biden, and if we print that again, we'll have only Biden changed because we're making a copy here. Okay, one last thing that I want you to see is this one, the to do method. If you have not completed some function, like take a beer, this function is not completed yet, you can say, okay, let's declare this with the to do function. If you open this, it will just throw not implemented error with the reason that you're giving inside. So it's just a stupid shortcut, and you must try catch it, otherwise you will have an issue with when running the code. For example, this is useful, of course, if you have non-implemented functions that must not be reachable, because if you call this function, the app will crash, and I think that's not what you want to achieve, right? You want to have code that runs without exceptions, and that runs well, of course. So that's almost all for today. Maybe, yeah, I think we've seen all we had to see today. Next time we'll go with the coding conventions. Let's see. Yes, with the coding conventions. Let's hope this is less boring, and then we'll go on with concepts with types next time. Okay, so thank you for watching this live stream. I hope it was helpful. If you have any doubts, please tell me in the comments, and I will try to answer them in the next video. Thank you. Remember to subscribe also if you want to see more content, and also remember to check the GitHub page to have a recap of what we've seen in the lessons. Thank you.